Hey YouTube, welcome back to my LeetCode series. In this video we're going to solve question 442, find all duplicates in an array. In this series I solve problems that I've never seen before, so the purpose of these videos is for you to be able to look into what I'm thinking in my thought process and for you to learn how to critically think and become a problem solver. The approach to LeetCode for a lot of people seems to just be memorizing solutions, and the problem with that is if you come across a problem in an interview that you've never seen before, you're going to get absolutely destroyed because you'll just be a potato. You'll just sit there and not know where to start. So these videos really start with the brute force solution, how to optimize and edge cases and whatnot. So if these videos help you, please make sure to drop a like and subscribe for more content like this. And let's get started. And one more thing else, another thing I wanted to say is that the list of questions we're going through are curated from this repository that I've created. I'll have the link in the description below for this as well. And we are in the cyclic sort section, and we are at, I guess, this 442. So yeah, let's get started. The question says, given an array of integers where the range of the integers is between 1 and n, some elements appear twice and others appear once. Find all the elements that appear twice in this array. So the brute force solution is very simple. This is going to be O of n squared time with constant space. And what this does is loop I from 0 to n, and then loop j from I plus 1 to n, and if I and j, nums at I and nums j overlap, not overlap, they are the same. If nums at I is equal to nums at j, then push nums at I to output. And then break. A better solution is to use the set solution, where we use space. So we have a set, and then we insert all nums in set, and then we loop through nums. And if nums at I, we have like a for n of nums. If n is in set, then we push it to the output. So now they're asking if you can do this in O of n time with constant space. So what we can do is we can do something like cyclic sort, where we use the input array itself, set the values to negative, and then any value that is positive, it means that we have not seen that number. So for example, running through this test case right here, 4, 3, 2, 7, 8, 2, 3, 1, we are going to set the, and we'll set the value -1, because we need to map them between 0 and n minus 1, and the values are between 1 and n. So here we set 3 to negative, 0, 1, 2, 3. Then we're at 3, we set this to negative. Then we set the first element to be negative. Then once we're at 7, we set the sixth element to be negative. So 0, 1, 2, 3, 4, 5, 6. Then the 8th. Then the second, again, 0, 1, 2. Wait, no, I just immediately jumped. Okay, so see, okay, that's one slip up. You have to make sure that when your patterns are so ingrained that when you apply the patterns, they are actually giving you the answers that you want. This would be finding the missing numbers, not the duplicate numbers. So what happens is we set the values to be negative, which is still what I want, and that means we've visited them. But then if we're at 2, you see 2 is the first number that's duplicated. If the value that we're trying to flip has already been set to negative, that means we have already seen a 2 in this array. So since 2 maps to the first index, we want to set this to negative, but we already see that the value is negative, so that means we've already seen 2. So then we push to the output 2. Then 3, we want to set the second element to be negative, but we see that's already negative, so then we push 3 to be a duplicate. And then 1, we set this to negative 4. So I'm going to quickly code this because it's a pretty simple solution. If the length is 0, then we can just return the output. Actually, it doesn't really matter. So we loop through the numbers, const n of nums, I believe. And what we do is we do const index is equal to the absolute value of n. Then if the output at index minus 1 is negative, that means we've already seen the current index. So we want to push the index is n minus 1. We want to push the absolute value of n to our output. And then we simply return the output. I believe that should work. So what's the problem here? Otherwise, we're not setting it. So output at index minus 1 is equal to, not output, nums at index minus 1 is equal to negative nums at index minus 1. So we're taking the index, and then index is the n minus 1, and if the, not output, if nums, see I'm moving a bit too quickly here, great, and the solution is O of n time with constant space. And are there any edge cases that we forgot to cover? So this should set this its own value to negative. We're setting negative 1 to not a number. Nums at index minus 1 is equal to negative nums at index minus, not index minus 1. It just equals, wait, yeah, no? When we're at 1, we should flip itself to negative 1. Because it's not already negative. Nums at index minus 1 is equal to the negative version of it. So index minus 1 should be 0, no? Why would it not be 0? The absolute value of n is 1, minus 1 is 0. It's negative 1. Oh my goodness, we are already subtracting 1 from it. Yeah, so this is me just making stupid mistakes. Come on. Come on, LeetCode. Right, because I'm logging. I had too many console logs. Come on, LeetCode. Yeah, there we go. So that's the solution. O of n runtime with constant space to 442. If this video has helped you in any way, please make sure to drop a like and subscribe for more content like this. I'll see you in the next video. Peace.